Okay, my dear students, today I will solve the problems asked in IES prelims, subject network theory. Total 16 questions came, so all 16 problems I will solve now. All of you listen carefully. We will start with a path is a particular subgraph consisting of an ordered sequence of branches. This word is important. Consisting of an ordered sequence of branches having which of the following properties? At all but two of its nodes, called internal nodes, there are incident exactly two branches of the subgraph. At each of the remaining two nodes, called terminal nodes, there is incident exactly one branch of the subgraph. So this problem comes under graph theory. If I take an example of this graph, this is the graph. So in this I have to draw a subgraph. Before I draw, what is this called as? Is a vertex. Vertex or node. Now if we draw the tree, we can draw so many ways, but is asking ordered sequence of branch. Tree edge is a branch. Tree edge is a branch. What is mean by edge? All are the edges. In a tree, edge is a branch. So if I take a, is not asking tree, is asking a subgraph. But subgraph can be selected like this. So these branches are in a sequence. And this node, they are the internal nodes. Internals that are incident exactly two branches of subgraph. So this incident node contains this branch and this branch. This is also having this branch and this branch. So this is having two, this is having two. So this is called as a internal node. Whereas this one and this one called as terminal nodes. Terminal nodes. So this is incident exactly one branch. So this is having one branch, this is also having one branch. So both these statements are satisfied. That's why both 1 and 2 are correct. Both 1 and 2, both the statements are valid. So if you draw the subgraph like this only, like a ordered sequence of branches. If you take in other way, it will not be satisfied. Under this condition, these two statements are satisfied. So we can answer both statement 1, 2 are correct. So this is another interesting problem. What is the value of source current IS of the given network in the figure? So observe this problem. This will form a bridge network. It is a bridge network. and not balanced. 12 into 9 is not equal to 4 into 8. If it is balanced, we can consider this like open, then problem is simple. But unfortunately, here bridge is not balanced. So bridge balance concept cannot be used. And you can't use series parallel. Series parallel will fail anyway. So you have to change either above delta into star or below delta into star. I prefer below because these numericals are lower side. So if I change, so 4 into 6, 24, 24 by total, 6 plus 4, 10, 10 plus 9, 90. And 6 into 9, 54. 54 by, again total same, 90. And this value is 9 into 4, 36 by 90. Now this 12 and 24 by 9, 19, they are in series. So what is this value? 252 by 90. Then 18 plus 54 by 19. This will be 396 by 90. Now these two are parallel. So how do you simplify 252 by 19 into 396 by 19 by 252 by 19 plus 396 by 90. So 252 into 396 by 19 square, 19 into 19, this will be 19 by 252 plus 396. 648. So 119 will go. This you have to simplify. 3 1 ja 3 3 3 2. 3 2 3 1 3 6. Then 2 1 ja 2 2 ja 2 6. 2 1 8. Then 2 6 2 3 2 5 4. 3 2 3 1 3 1 24 3 8. And 3 into 6 3 3 7. Then 6 1 ja 6 2 22. So it is 7 into 22 by 90. 7 into 22. So 154 by 90. Now what is the total R equivalent is 154 by 19 plus 36 by 90. This last 36 by 90. So you will get 190 by 90. This is 10 ohms. Now what is asking is IES. Applied is 120 volts, sorry 12 volts by 10. This is 1.2 amps. So A bit is correct. Since calci is not allowed, so I am doing like this. So IES getting good marks difficult, only speed is important here. All these calculations without calci you have to do it. Next problem. Which of the following properties of the circuits of a graph are correct? Again graph theory. Minimum number of branches possible in a circuit will be equal to number of nodes or vertices. So minimum number of branches. Any tree, if you take it, is the standard tree. This is the tree. So first statement is minimum number of branches. 1, 2, 3. In a circuit will be equal to number of nodes and vertices. This is a ground neglected, and hence we are considering this, this, this. So these three equal. So statement 1 correct. There are exactly two paths between any pair of vertices. Any pair of vertices. So these are vertices, these are vertices. Pair of vertices, two paths not possible. Two paths not possible. There are at least one branch in a circuit. Circuit means closed loop. So there are at least at least two branches in a circuit. So if I close these two branches, if I close these two branches, if I close these two branches, the third statement is also valid. So 1 and 3 valid. So therefore B bit correct. Okay. So graph theory 2 questions came. Next. What are the open circuit reverse voltage gain, short circuit forward current gain, respectively for the two-port network shown in figure? Open circuit reverse voltage gain. What is reverse voltage gain? V1 by V2. V1 by V2. Under what condition? Open circuit. So which one is open? That you have to decide based on the options given. So for these options, you have to take input side open. So this I am open, this voltage V1 and current 0, 12, 3, 6 and here V2. So we want a V1 by V2 ratio. When this current is 0, what is this V1 will come here, see. Now V2 is applied 3-6 series. 3-6 series. So what is V1 from this? V2 into 6 by 9. This is 2 by 3 V2. So V1 by V2 answer is 2 by 3. But 2 by 3, so plus 2 by 3 given, only plus 2 by 3. So straight away we can answer here only. Plus 2 by 3 is only here. We got 2 by 3. With another plus 2 by 3 is given, we have to find other one. So we can straight away answer here C. Let us also try, are you getting minus 2 by 3? But in the exam point of view, this is enough. You can select C. Short circuit to forward current gain. Short circuit, forward current gain. Forward current gain means I2 by I1. Here we have to short output. This is shorted. V2 is 0. I2, 3, 6, 12. Now this current is I1. So we want short circuit forward current. I2 by I1 we want. So what is this current when I1 is entering? What is minus I2 value? So I1 is entering. This current is coming up to here. Now this is shorted. Current is dividing between 3 and 6. And this side current is minus I2. Incoming current is I1. Opposite resistance 6 by 9. This is nothing but again 2 by 3 I1. What we want I2 by I1, so minus 2 by 3 amps. So therefore C is correct. So like this we have to answer. There is another problem. Two-port network. What are the open circuit transfer admittance? Transfer admittance. Admittance means it's a transfer. Admittance is basically current by voltage. So transfer means output current by input voltage. So I2 by V1. This is what asking. So here we, under what condition? Again open circuit. So make this open. This current is 0 anyway. Here V2 is applied. Then I2 will come. And this voltage is V1. Now this current is 0. Observe carefully. What is entering here? I2. I2 is dividing between, some current will flow in this path, some current will flow here. So this current is, call it as I2 prime. So what is I2 prime value? Incoming current I2, opposite resistance 10.5 by 10.5 plus 21 plus 42. So I2 prime in terms of I2. But what we want to V1. V1 is 42 I2 prime. 42 I2 prime. So this is 42 into, what is I2 prime? I2 into 10.6 by 10.5 by 10.5 plus 21 plus 42. So here V1 by I2. You simplify this one, you will get 6. But what we want, I2 by V1, 1 by 6. But here 1 by 6, two answers are there. So definitely A, D wrong. It can be B or it can be C. So compulsory you have to find other also. Negative short circuit ratio. negative short circuit, it's a current ratio for the two-port network shown. So again, if I redraw short circuit, this is shorted by 2, 21, 10.5, 42. Here V1 is there, I1 is there. So when this is shorted, what is the current in this 10.5? 0. Current will not flow. So incoming current I1 is dividing between 21 and 42 only. So what is I2? I1 into current division formula, 42 by 42 plus 21. So this you have to simplify. So from this, what is asking negative short circuit. So minus I2 by I1. We'll get 2 by 3. 2 by 3. 1 by 6, 3 by 2 is there, 2 by 3 is there. So C is correct. So compulsorily both you have to find. Otherwise, elimination method cannot be applied here. Now the dynamics of an nth order single input, single output system can be written by vector matrix differential equation. This comes under state variable analysis. State equations are given already. So state equations are what? X dot equal to Ax plus Bu and output y equal to Cx plus Du. This is the standard form. But here only Cx, this is not there, 0. Now if you have, what is the important point here? Single input to single output. Single input to single output. The C size is always, this is the fundamentals of state variable analysis in the control system. You will study the size of C is always Q by N. This Q indicates number of inputs. Number of inputs. So therefore it is 1. What is N? Number of state variables. State variables. So therefore, what is the size of C now? 1 by N. It is 1 by N. Next, for the state variable formulation of RLC network, which one of the following statement is correct? Voltage across inductor, current through capacitor are the state variables. Wrong. Current through inductor is chosen as a state variable. Wrong. Only voltage across capacitor is chosen as a state variable. Wrong. The current through the inductor and voltage across capacitors are chosen as a state variable. Correct. So therefore here D is correct. Is another problem in again state equations, but here this key what is given is not matching. So let me solve. I of t is given, state variable formulation of RLC circuit is asked. So what is the equation is I of t is equal to outgoing IR plus IL plus IC. Now here I am taking state variable as x2. Voltage across capacitor is the state variable, x2, and current flowing through inductor is another state variable, that is x1. Current through inductor is a state variable, voltage across capacitor is a state variable. So in that sense, what is the IR current? Voltage by resistance. What is voltage across? All are parallel now. So x2 by R plus IL. What is IL? Is the state variable x1. Then IC is C and dV naught. So that means x2 dot. x2 dot. From this, what is x2 dot? Is nothing but x1 plus x2 by R. It is coming this side now, minus, is also minus, plus I of t. What is I of t given? I naught sin omega t. And here C is there. So here by C, then RC by C. So if you write a state equation form, what is the standard form? x1 dot, x2 dot, because two state variables. So write in matrix form. This is x1, x2 plus input also there. So x2 dot is equal to here minus 1 by C minus 1 by RC here. RC. So if you multiply with x1, minus x1 by C minus x2 by RC, and is equal to, what I have to get here? I naught sin omega t by C. This is second one. But what is first one here? If you see, what is IL? Voltage x2. What is voltage x2? Is nothing but LdI by dt. LdIL by dt. That means it is derivative d by dt of x1. So it is nothing but L x1 dot. What is x1 dot from this? x2 by L. So x1 dot is equal to, if I multiply x1 not there, so 0. Here 1 by L. So I should get only this equation. Only this equation should come. So 0, 1 by L, and this value is also 0. So this is the correct answer. Here no answer is matching, something wrong, but this is the correct. In the figure, the switch is thrown from position 1 to 2 at time t equal to 0. Before it is throwing to 2, the initial conditions are IL0 minus 2 amps, VC0 minus 2 volts. What is the current I of t after switching action? So after it is connected to 2, it is a series RLC, second order, but definitely at infinite current will be 0. But here it is e power 3t, e power 2t. So CD cannot be answer. Because at t equal to infinite, these answers are coming as infinite. This I of t cannot be infinite. So CD definitely wrong. And based on AB, we have to decide. What is given? IL0 minus given 2 amps. What is IL0 plus? Is also 2 amps. And what is infinite steady state current is compulsory 0, any second order. because capacitor behave like open. So initially at t equal to 0, 1 plus 1 is becoming 2. Here also 1 plus 1 is becoming 2. First condition satisfied. At t equal to infinite, both are becoming 0. So with the help of this, you can't decide A is correct or B is correct. Now after it is connected to position 2, now we have to write a mesh equation. That is nothing but 5 is equal to 3 into I plus L1 di by dt plus the initial voltage of 2 plus voltage across capacity is 1 by C. So 1 by 2 given, integral 0 to t, because initial voltage already taken. Now I dt. Because of integral, differentiate. So 0 equal to and 3 di by dt plus d square I by dt square. Derivative of 2 0, then 2 will come numerator, so 2i. If we change into d form, it will be d square plus 3d plus 2 into I equal to 0. So this second order we have to solve. So it will have two roots. So minus 3 plus or minus root of 9 minus 4 AC. 4 into 2, 8 by 2a. So you'll get 2. Minus 3 plus or minus 1 by 2. One root is minus 3 plus 1 by 2. This is nothing but minus 1. Another is minus 3 minus 1 by 2. This is minus 2. So two roots are there at minus 1 and minus 2. If you observe A and B, here minus t minus 3, here minus t minus 2. T coefficients are the roots. When you are solving any second order equation, these t coefficients are the roots. Here minus 1, minus 2 are the roots. Therefore, B is correct. B is correct. Two roots are real and not equal. Under that category, you have to write. So if you solve completely, e power minus t plus e power minus 2t will come. That is the answer. What is the output voltage V0 of the circuit shown in figure? Here RC is connected parallel, but input is a current source. Input is a current source. So this also elimination method you can't apply. You have to solve. So this is, what is the nodal equation if you write? 3 e power minus t is the current, is equal to, the voltage here is V0. And this is entering and leaving. What is leaving here? V0 by 10K. Current flowing through capacitor is CdV by dt. 25 micro and dV0 by dt. Again, if you divide dV0 by dt plus V0 by 10K, that is 10 power 3, and 25 micro, 10 power minus 6 is equal to, I am dividing with this value, is equal to 3 by 25 into 10 power minus 6 e power minus t. So this you simplify, you will get d plus 4 v naught is equal to 120 will come. 120 e power minus t will come. So this equation we have to solve using Laplace transform. Using Laplace transform. So what is the Laplace of this one? S into v naught of s 4 v naught of s is equal to 120 e power minus t is 1 by s plus 1. V naught of s, if I take common, we'll get 120 by s plus 1 into, here you'll get s plus 4. So this you have to solve using partial fractions. A by s plus 1, b by s plus 4. What is a value? 120 by s plus 1 cancel, s plus 4, simplify it as equal to minus 1. So 120 by minus 1 means with 3. So this will become 40. And what is b value? 120 by s plus 1 is equal to minus 4. This is 120 by minus 4 plus 1. So minus 3. This is minus 40. So what is v naught of t? 40 e power minus t minus 40 e power minus 4t is the answer. So 40 comma e power minus t minus e power minus 4t. C is correct. So in this, if the value of E is given 100 volts, RC value is also given, the capacitor current I of t at t equal to 150 milliseconds. So this is simply first order. Any first order, first find out tau. The tau is RC 10k into C value. C is 10 milli. You will get 100. Kilo and milli cancel, 100 seconds. Then we want I of t expression. What is I0 plus? Immediately switch is connected, capacitor short. So 100 by 10k. K means 3. So what is this value is 10 milliamps. Then what is the final current steady state? Capacitor open 0. So we can write expression for I of t directly. Final 0, initial this. So it looks like 10 milliamps e power minus t by tau. T by tau. T by tau. But he is asking, what is the question asking? At I of t at t equal to 150 milliseconds. Therefore, 10 milliamps into e power minus t. T is 150 milli. 150 milli, that is 10 power minus 3 by tau. So what is the tau value? 100 seconds. It's 1.5 milli. So strictly speaking, 10 milliamps e power minus 1.5 milliamps. Then this is milliamps, so 1.5 also milli. We are not mentioned that as milli, but this is the correct answer. So 10 is only 1 is having, even other things. So using elimination method, you can answer C. Because 10 already got it now. 10 already got it. Directly we can answer. So C is correct. This is another problem again on first order. A capacitor figure shown below, 25 volts on it with polarity shown at the time switch is closed. What is given? Vc0 minus given 25 volts. The expression for Vc of t is asking. And obviously Vc0 plus is how much? 25 volts. What is the final Vc infinite? Capacitor fully charged to 40. Then we want to tau. Tau is 200 into 1000 into 10 power minus 6. So this is 3 to 5, so 0.2 seconds. 0.2 seconds. So therefore Vc of t is equal to final is 40, initial 25, final 40 e power minus t by tau. Tau is 0.2. So you will get 40 minus 15 e power minus 5t. Okay, so A is correct. A is correct. So you can't use any elimination method here. Completely you have to solve. What is the value of the maximum power transfer to the load resistor RL in the given circuit? We have to use clearly Thevenin's theorem here. Maximum power transfer theorem is extension of Thevenin's. We have to find out Thevenin equivalent first. V Thevenin, R Thevenin, then connect the load. V Thevenin, R Thevenin, RL. What is asking P maximum? What is the formula? V Thevenin square by 4 into RL. But to get the maximum power, RL is equal to R Thevenin. So we have to find R Thevenin and V Thevenin first. So to find R Thevenin is always looking from the load. And voltage source short, current source open. 6, 12. This is 3. Current source open. Again 2. 2, 3, 6, 12. So you will get R Thevenin equal to 2 plus 3 plus 6 parallel with 12. Simplify, you will get 9 ohms. Next, you have to find V Thevenin. 12, 6, 3, this is V Thevenin. This current is 2 amps. 3, 6, 12. Here 12 volts. Now two source problem. To find this V Thevenin, assume some voltage Vx. Vx is unknown. So write the nodal equation here. 2 ampere current is entering. This 2 is going like this. 2 is entering, equal to Vx minus 12 by 6 plus Vx by 12. Vx by 12. So here we have to solve for Vx. Okay. So straight away I am giving answer. Vx will be 16. But what we want to be it. Started positive, go to negative. That is 3 into 2 plus Vx. Vx is 60. We'll get 22. Now power is equal to 22 square by 4 into RL. What is RL? 9. So this you simplify, you will get 13.44 watts. So C is correct. Without calci, how to do it? You will get some nearest to approximately, you can verify. In the figure below, value of voltage drop across resistor R1. And this R1, R2 connected in series. So this is an easy problem. VR1 is equal to applied voltage 40. We want across R1 100 by 100 plus 300. So simplify, you will get 10 volts. B correct. Which one of the following represents a single element such as voltage source or a resistor? Is a branch. Not the node, not loop. Loop circuit same. So branch following a single element such as a voltage source or a resistor is a branch. So this also comes under graph theory concept. So I am closing the session. So these are the problems asked for ECE students. Thank you.